Hi everyone. This is Robert again. It's been quite a little bit of time since I last uploaded a video. Today we're going to be going through a small, well, it's sort of important business calculus final exam walkthrough. And yeah, without wasting too much time or hesitation, let's get started. So the agenda for today. So I'm first going to go through a quick list of test taking tips, strategies, and so forth to help prepare for the final exam. And I'll do that right now. So when you receive well, in my opinion, whenever you receive like a test or an exam of some kind or a quiz, any type of assessment, um, always make sure that you don't leave any question unanswered, um, and try to proportion out your time equivalently between all the questions, or at least between the questions that have the most points, and then saving the questions with the least points for the end. Um, I've seen the final exam. It doesn't look too complicated. I think you all can solve it very easily if you've been applying yourself. Um, and if you've been preparing very well. I think the previous quizzes and homeworks and tests they all do a great job in helping you get ready. Um, when you receive your test, to get back to not trail off too much, yeah, make sure to try every question to the best of your ability, and also start with the easy questions first. Um, that's what I would recommend. Do the questions that you know first, that you know for sure that you're going to get points, like full credit for that question. Then move on to the questions that maybe you're bogged down a little bit in. Save those for the second set of questions, and then save the questions that you're very unsure about. Like, and this should be maybe like one part to one question somewhere. I would save those questions for the very end. But above all else, make sure that you answer every part of the test. For today, I'm going to run through all, or at least most of the types of problems we've run through before, and explain my process along the way. That being said, this video is going to be sort of crammed, so I'll try to be as thorough as possible. But if I do skip over something, or if I do make a small mistake somewhere, I know I made one mistake somewhere later in this video, but I'll be sure to call it out. But if you find something that I don't call out, just make sure to let me know. Um, yeah, what to do when you're stuck or bogged down somewhere. So we've covered that. The goal of this video will be me walking through a number of concepts from the beginning and end of the course. So if there's a concept that you've already got down and are fully ready for the day of the test on that concept, then feel free to skip parts of this video. I don't want you to waste your time. I don't want to waste your time. I'll try to be thorough, but because I've already have some content that really expands a lot on certain topics, I might skip some unnecessary regurgitated details for one problem. Regardless of how things go, I really mean this. I wish you nothing but the best of luck in preparing and doing well in the final exam. I've seen you all grow in your business calculus prowess, and I'm looking forward to seeing how you all do. And yeah, I think this has been a really fun course to be a grader for. So, thanks for giving me papers to grade. All right, and yeah. Oh, what's different? What's going to be different about this video is I'm going to be narrating my run through of a couple problems. So I've already recorded my run through of some practice problems I made on my own. And again, if you see a place where I made a mistake that is like very big, just let me know and I'll change it as soon as I can. And yeah, sit back and enjoy the show. All right, let's get started here. So, all right. Just make sure it's the right one. Oh, I'm also going to be making this video double speed because this takes quite a bit of quite a bit of time. I don't want to take forever. So let f of x equal 3x squared plus 2x plus 1. First, find the average rate of change between the points x plus h and f of x plus h, and x and f of x. Second, write this expression as the limit as h goes to 0. Lastly, check if the derivative of f of x equals the limit, this limit upon evaluation. So first, I'm just rewriting the arc equation. This is very very beginning of the course. Yeah. So, I meant to write numerator in that part, not denominator. Yeah. So I'm just substituting x plus h where x is, and then subtracting f of x from that function. And here I'm combining the like terms. And I tried striking through some of them, but I I underestimated the PDF toolbox. And yeah, now this should have been the denominator. Yeah, x plus h minus x just simplifies to h. I'm also I'm listening to music, and that's why you can see the volume change. And yeah, now you can factor out because you have all h's in the numerator. In the numerator and one in the denominator, you can factor out and cancel out an h. I also timed this originally to be, I shot for 40 minutes, but I went well over an hour, which is why we're doing double speed. Yeah, so the h's get canceled, and you're left with 6x plus 3h plus 2. And yeah, just boxing your answer, make it easier for the grader to see what you have left as an answer. Now, when you express the limit, it's just asking you to express as a limit as h goes to 0. So this is your answer by itself. That's just the answer of part 2 of the question. Lastly, we want to check if the derivative of f of x equals a limit as h goes to 0 of this expression. So yeah, first I'm wondering, does it equal the limit? Well, what does it equal at first just by itself? You can solve this using the power rule. And yeah, using the power rule, you just move the exponent down, multiply it by the constant if there is one. So like 2 times 3 times x to the 2 minus 1, which is just x. And 2x just becomes 2, and just simplifies to 6x plus 2 is the derivative. And does it equal the limit after being evaluated? So now you want to plug in h for 0 for h, which is just 6x plus 3 times 0 plus 2, which is just 6x plus 2. And yeah, it's a thumbs up that they both equal each other. Yeah, at first I thought that double speed was going to be actually a little bit too quick, but I think this is a good pace. We're kind of slowly. All right, so yeah, this is a question that you wouldn't, of course, see on the exam. This would be like, this would be this would be torture just for one question. The purpose of why I made this question uh, is um, is because I wanted to give you sort of a feel of every type of problem we've taken the derivative for. Um, and you'll see later, like in like a couple minutes or so, that I did take the derivative of this incorrectly. Um, because yeah, I applied quotient rule, but only part of the way. So yeah, I'll just point it out later. But yeah, this it's just supposed to be like every type of thing we've taken the derivative of every type of term. And because derivatives add, you can just take the derivative of each part, each term between the addition symbols. So that means taking the derivative of x to the 5 plus the derivative of x squared minus 1 over x cubed plus and so on. You don't have to all have to think of it all as just one, um, even though the sum of them all equals equals the function. So yeah, just apply power rule here. 5x to the 4. Yeah, so this is the part I'm talking about. So I took the derivative of the numerator times the denominator minus the the numerator again times the denominator. So I should have taken the derivative of the denominator here. So just to put that together, it should be this term right here should be minus x squared minus 1 times 3x squared. And yeah. Here, this is just the derivative of, well, this is a product rule. So yeah, product rule is just so the derivative of 1 times uh, the other, well, it's if you have two functions f and g and they're multiplied against each other, the derivative is f prime g and g prime f and the sum of those two. And this one's ln, so ln's a little special. Um, you do 1 over x, but also this is 4x, so you need to multiply by the chain rule. I mean, you need to apply the chain rule. And here, yeah, here it's 1,000 to the x. Yeah, you can't apply power rule here because the exponent is a constant. The exponent's a variable. E to the minus 40 pi, that's just a really big number, but it's not like it's a constant. So it doesn't depend on anything. So it doesn't change the slope. And yeah, the 10th root of x to the 3 is just can be rewritten as x to the 3 over x to the power of 3 over 10. So you bring that down, subtract 1 from the exponent. And yeah. Now this part I honestly should have just skipped a little bit because, or maybe I should have caught the caught this term, and how I didn't do the numerator correctly. But yeah, another thing I would say, if you do have extra time at the end, make sure to double check um, the problems that you're 100% sure about, to make sure that, okay, like, I know what I did is correct. I don't have to come back to this problem anymore. And then just to save time, to make sure that you go back to those questions that you're iffy about. Oh, and here I already have a TI Inspire run through review document. And here I'm taking the derivative just to double check. Um, and my settings were actually set to be exact and not approximate. And I just plugged in a value, because if the value of the derivative at a point on the calculator is the same as what I calculated at that same point, then I should have calculated for the right answer. But as you'll see, I actually I got that answer above, but something a little bit more than that. So yeah, I say that the second term is approximately 0 and can be ignored. These functions are similar when I meant to say that they're actually exact. They are not, though. They're actually they're not exact. They're close, but they're not they're not exactly the same. So yeah, just the second term should have been. I should have properly applied the quotient rule. Now this one is a type of question you've seen all the time: revenue minus cost, and then profit, finding the max and min. Part 5 of this question could not be applied, and I only partially answered part 4. Part 5 can't be applied because there technically is no average minimum cost of the function. But if you do want to do that problem, then I would just do this problem all over again and pretend that I have no fixed costs. And then you should be able to find a minimum with that information. So yeah, the demand of gold bars is 2,500 minus 0.001x, where x is the selling price of a gold bar in US dollars. And I changed the color just to match with the gold. Revenue equals price times quantity sold. It does not take into account things like cost. So yeah, it's the demand for gold bars, and multiplied by the price of gold bars, which is x. In hindsight, one thing I wish I could have done for this video is made like a fun like account video where you have like an interest rate, continuous compounding, and all that. So I would recommend that's something that you should look up on your own. We definitely had midterms and quizzes in the past where that's come up, so I'd recommend that. And yeah, this is finding the cost function. So costs are variable cost plus fixed costs, and that's just to check that I got something done. And I would actually do this on a real test or quiz, just to make sure I have every aspect. Variable costs are dependent on the amount of gold Robert procures, whereas fixed costs they don't depend on the gold on the variable. Their fixed costs are invariable, so they don't change. And make sure to add your costs together. All right, yeah. So variable costs are how much it costs for every gold bar multiplied by how much it costs for every gold bar to be found, not the price, times the number of gold bars I actually produce, plus 5,000, which is the fixed cost for the boat. So profits equals revenue minus costs. P of x equals R of x minus C of x. Oh, and here I realized that I actually take the derivative of the profit function incorrectly, but I really quickly correct it. So yeah, just a quick product rule, and I incorrectly apply the power rule. The fixed costs don't change anything, so they just go away. This is just me double checking my answers, and I know something's gone awry if the numbers are off. And yeah, I'm using a Google timer. Yeah, now I'm just trying to figure it out, and I think I do when I see what the calculator spit out as the derivative. Didn't properly take the derivative before, but was caught here. So it's always good to double check just in case because of situations like this. So yeah, each gold bar, well, we found a critical point, which is $1,250,250. Um, and yeah, no, this is just me plugging it in again just to make sure because I chose really big numbers for this, and then now I'm doing the first derivative test. Using the first derivative test, we can see it's a maximum because we go from negative to positive. I mean from positive to negative, excuse me. I didn't check the second derivative, but I'm pretty sure we could have used that too. Solving for the critical point, 1,250,250. Robert should charge $1,250,250 for each gold bar. And using the first derivative test. Yeah, and I think this is where, yeah, and some typos here and there. So if they just want the average cost, you just divide by the variable in question. So take your C of x divided by x, you have your average cost, which is A of x. If you do this question, just make sure not to include fixed costs or pretend like the fixed costs for some reason don't exist at this point, just because you can't really find the minimizing cost. Okay, so that's part one. And yeah, try part five if you want. It's basically whether or not minimizing or like maximizing profits or minimizing costs, maximizing revenue. I mean, or minimizing costs. Which one would be better in terms of profits? So yeah, so try that if you get a chance. And now this is part two. Using the table of points below, find the critical points, the inflection points, the maximums. The maximums, the minimums, the inconclusive points, points where not much can be drawn from in the way of conclusions. Use the derivative test, both the first and or second, to justify your answers. So yeah, critical points are where f prime of x equals 0. So whether or not they're max or min, that's a very special case of a critical point. Just because you have a critical point doesn't mean that it's a max or min, but if you have a max or min, you have a critical point. So it's sort of like a circle square, square rectangle situation. I really should have circled the x values, but yeah, critical points are x equals -3, x equals 1, and x equals 70. The inflection points are where the second derivative changes sign, therefore they exist at x equals 0, and not x equals 70. Because if you look, because signs do not change on either side of x equals 70. And yeah, I've listened to some pretty good music. And yeah, I really tried to make it work, like with no interactions. And yeah, just an X to make sure, like I know it's not an inflection point. The maximum of the function can be located at the critical point x equals -3 using the first derivative test. F prime of x equals -5 is a positive value. So that's looking at this right here. And f prime of 0 equals negative using, so yeah, that's this part right here. Right here, that -3. Using the second derivative test, you have your critical point at x equals -3, and f double prime of -3 is a negative, concave down. Yeah, so just looking at the value of the critical point at the second derivative of the function. And yeah, I forgot to specify that they're relative. Just saying max or min could imply that you're talking about absolutes and not relative extrema. So this type of problem you can be expected to be asked, like what's the critical point of the relative max or relative min, and so on. Yeah, x equals 70 is not a relative max or a relative min because the first derivative test fails since both sides of f prime of 70 are positive, and because the second derivative test also fails. So if they both fail, you can't draw any conclusion from either of them. And I would say it's very unlikely that like both of them fail. Like if one fails, you should always check the other, but like most of the time, like one or the other should work. But it's good to be thorough, and practice never hurts. All right, and this is the final answer. Critical points: x equals -3, x equals 1, and x equals 70. Relative max is x equals -3. Relative min is x equals to 1. And inconclusive points, where you can't draw any meaning, is when x equals 70. So yeah, you probably won't get a question about inconclusive points, but it never hurts to be able to draw the distinctions. And yeah, I changed the function. This is what it's supposed to be: 2.5 x cubed minus 7.5 x squared plus 15. So make sure to graph that correctly in your calculator. We want to find the inflection point and label that point in your graph. So this one, the concavity shifts just once, so we should only have one inflection point. And here I'm solving for when the second derivative equals 0. Not to get the inflection point, but to get a candidate for an inflection point. Because just because the second derivative equals 0 doesn't mean that it's an inflection point. This is just me testing out, doing the second derivative test. So as you can see, it changes from negative to positive. And now what I'm doing is I'm finding the intersection. I'm finding the point in y. So I could have done this just by plugging in the value, but like here I could have done f1 of f1 of 1. I could have done that, f1 in parentheses 1 inside to get the value of y, but you can also do some pretty cool stuff with your calculator like this. So yeah, so that's the point in our graph. And yeah, I didn't even write it. You should write that like the point is x equals 1, y equals 10. And now what I'm trying to find is the I think the minimum maximum, possibly. Oh no, so I'm looking at the first derivative and seeing. So yeah, so since the second derivative is the first derivative of the first derivative, basically saying how fast is the function changing, how fast is the rate of the change. So yeah, show to use. Actually, go back up a little bit. Oh, okay. Oh, here we go. Since the second derivative is the first derivative of the first derivative, and because we've performed and showed using the first derivative test on the first derivative that x equals 1 yields the relative min of the first derivative, we can conclude this is the fastest decrease. Now say we want to find the integral of this function from 0 to 5, but say that we don't know how to take integrals yet, using 5 left rectangles. Find the area. So yeah, this is just something you've been familiar with. I meant to say five left rectangles, not triangles. Part C, recall sums. Because we're using left rectangles, take the left side of the width when finding a height. So yeah, f of 0 equals height 1, f of 1 equals height 2, and so on. But don't use f5 because we're only looking for 5. Because our calculations are for left rectangles, we're using only the left hand side of our function or our values. So this is just me calculating all the heights out. Since our width is 1, we can just add these all together. So if our width was a different size, but like we would need to change this. So like if it was half instead of 1, it would be an area equal to 50 instead of 100. A faster way to calculate for the sum is using the sums operator in your calculator. I wanted to do a video on this, but I haven't had the time recently. But one quick way just to double check this instead of trying to do what I did here is taking the integral. Your calculator is more than able to do that on its own. So you put the number of rectangles you are solving for in the top above the giant sigma. So we're doing 5, but because we're starting from the left, we have to subtract 1 because the number of numbers between 0 and 4 is 5. And you put the heights in the right. Since our width is 1, we don't need to multiply it here, but if it was a different width, we would need to pull it outside as a common multiple. And yeah, that's what I was just saying before. And yeah, I do try to do that later in the video, but it doesn't really work out so well. So now, say we do know how to take integrals. Let's find the integral of this function from 0 to 5. And this is just finding the integral again. Oh, you know what? I think I might have accidentally made it so that I might have done it so that 15 was actually might have turned into 0. I might have taken the derivative of 15 instead. So yeah, my apologies. I was only thinking about like time here. Yeah, so that should be 15 15x. Yeah, so if I added 15 times 5, I would have been I think I would have been closer. Actually, no, I would have been farther off. Um, but yeah, it makes sense that we would be off by so much since we're only using 5 rectangles. But if we were, say, using like 10 or 20 or 1,000, if we're using more, say, for instance, 10 rectangles, we get closer as we add more rectangles. In fact, the integral, when you think about it, yeah, so this is where I mess up a little bit. Or actually, no, I don't mess up here. I get I get different answers than what I got up above, and then now I start doing like I don't know what I'm doing. So I'm making mistakes right now, but I'll save this for another video. I might not be able to get to the video before the final, uh, but I think you've all had like enough experience with this, and I promise it gets a lot closer as the numbers increase. So find some time and do this on your on your own. It really doesn't take that long, and that's just the number of rectangles. All right, now problem 6 is the rate of change of a population in a certain country can be modeled by P of t equals 30t squared minus 20t plus 17. This is tens of thousands of people per year, 2 years after 1980. So this isn't population, this is population rate. Find the integral of the rate of change of the population function, P of t. So that's capital P, not little p. Using the reverse power rules again. And see, so yeah, this I forgot to include C up above here, but I also forgot. Yeah, never forget C. That's a very easy way to lose like 1 point on an integral question. If you're not given initial value, and here you are given initial value. Because we know 1 year after 1980, it's 50,000, and because our units are in tens of thousands, it's just 5. And if my calculations are right here, then yeah, it's just yeah, it's 3 minus 10 plus 17, and 5 equals 10 plus C, which means C equals 5, which means C equals negative 5. Therefore, P of t equals 3t cubed minus 10t squared plus 17t minus 5. Tens of thousands of people. T years after 1980, not per year. This is population. And yeah, that's the end of the video. So yeah, so thank you for watching. If you have any questions or comments, please feel free to reach out to me. And yeah, with that being said, I think it wraps up. Thanks once again, for taking the time. I've loved going through all your papers, and it's really interesting to see how like you improve from one quiz to the next and midterm to midterm, and yeah, really proud with all your work this semester. And yeah, I hope you do very well. And yeah, let me know if you have any questions or comments. I'm always one email away. And yeah, I hope you have a wonderful day and good luck on the rest of your finals and other projects and exams and stuff. Okay, bye bye.